Hello and welcome to this presentation on asset and cache workflow. These are two big subjects in Houdini, so I will just get started first with the asset workflow. As you all know, like digital assets are an integral part of working with Houdini, and there were times when this question came up like, were they any good or not? And I kind of had to argue with this example saying like digital assets are really the best invention in the world after ice cream. Well, I mean, come on, nothing can beat ice creams. So this is why I think it's important that that we kind of look into what we are currently missing, and currently we have interfaces in Houdini to manage, uninstall, and install assets and so on, and deal with the assets in the scenes. But what we don't really have is a good way to actually create them or provide the user some sort of way to create different iterations of the asset they're working with. And this is something that's already been there really. Like we have plenty of Python function in our Python API to call to, which would allow you to create your own kind of digital asset kind of versioning system. But we cannot expect that every user would go and create their own Python code, and that's why it's kind of like going back to the ice cream example. Like, if you do an ice cream party, you must have a waffle cone, and only the cool kids can make their own waffle cone. But we want to make sure that everybody can join to the party, and that's why what we kind of aimed for this release is to create exactly this system where by default in Houdini you can just easily manage, copy certain assets, version them up, work with different versions, and so on and so on. But without the actual complications of a complex pipeline. So we are aiming this to be not for studios, because studios, as I said, has the ability to do whatever their studio requires. But what we want to aiming this for is really to bring studio kind of like simplified features to users who has no possibility to create a pipeline, but they still want to work fast and efficiently. And to demonstrate it, I will just create new digital assets. So I'll just put down a subnetwork here, and after that I can right click and create digital assets. So this entry here been there for a long time. So here I have some very basic options to choose from, and then I can say this should be my I create a namespace with my name, and then the purpose, which is dev, and then some ice cream asset, and then everything updates automatically. This is the label which you see in the tab menu entry, and then the file name. And the thing here is that you can, if you want to, let's say, create an embedded one, you actually have to type here embed, which I never know how to write. So it's a pretty manual process. So instead, what we now provide is a new way of doing this exactly. So digital asset entry is the new entry where you can go on create new, and this entry labels are changing based on what kind of node you right click on, and because it's a subnet, it's kind of expects that you want to create a new asset from it. So create new, and then this will bring up a new window, and here you have a more granular way of defining your asset name and where it's going. So So as you can see, the type name subnet, which is now I actually want to, as I said, let's say an ice cream asset here. So you can see the same kind of structure I created in the previous window, dev ice cream 1.0. So all of these namespaces and the versioning surrounds the type name, and I can, disable them if I want to. But this is highly recommended that you keep the structure, because then the asset can be very easily identified and very easily, versioned up. And the menu entry where it should go, and by default things go to digital assets, but I kind of want it to go into my ice cream particle or entry in the tab menu. So I just type that, and you can see here the preview updates accordingly. And with display branching label, I can actually display the purpose, the branch in here, so that I can easily find it in the menu if I have different branches. Let's say I have test, beta main, but you can go to the preferences of these asset workflow, and you can add your own individual branches or authors and so on. And then lastly, where you want to save it, you can save it. We have a couple of presets. You can save it where your HIVE file is. You can embedded is just a preset here, so it's as easy as just clicking here, though we recommend it to actually save it into a file rather than using embedded. And then the file name, you can choose different option here. Again, automatic will just construct the file name based on your settings here, which is the recommended. It's good to store one asset into one file individually, so that you can easily associate one asset with one file. But in case you want to store multiple asset definition in one file, you can choose type name, and then everything will go into this file. And I will just go with automatic. And then prefix type category, this is handy because you might want to create an ice cream lop asset as well, or an ice cream top or whatever. And in that case, the file would start to conflict the file name. So this is just to separate it. And also it's much easier to find certain assets when you browse through them. And then I think I'm all ready. I just go create here. And as you see here, I immediately got an ice cream asset then. And if I go to tab menu, you can right away see that I have ice cream party with an ice cream. And I can put it down. It's the same instance, and I can already use it and populate it with ice creams. And one very important thing is the asset name and path bar here. So this will tell you which asset is currently in use by Houdini. So I only have one asset, so this is the only option I have, and it also tells you where is that asset definition located, if it's in a file, if it's embedded, etc. And the way to get this menu is if you go to assets and asset definition toolbar, that's how it's called. And I just have it show always, because this is, I'm very much used to have this on. So for me, this bar is not a visual noise. I'm very much want to know which version each asset is using, because it's kind of very important when you work with multiple assets. And it can save you loads of time figuring out what's going on. And then as a next thing, let's say I want to create, I done editing it, I want to create something, I want to create a new version. I again go digital asset save as. I can bring up the new window and manually edit it and saving it as. But I will just cancel it, and I show you an easier way. What you can also do is increase major version or increase minor version. And I will just say I will increase minor version, and you will see immediately that this is a simpler window, only telling you that the version from 1.0 is going to increase to 1.1. And you can still choose the save to options are here. But basically this is the main change which is happening going from 1.0.1 to 1 to 1.1. So create, and then now I have two different versions of the same asset, and now the asset bars, the way I know it is because if I can go to the asset bar, I can see both of these versions. And the other way to use this is, let's say you want to edit an existing node, let's say the platonic solid. So this is something that, you know, SideFX provides by default, and then you kind of decide, well, the number of solid types are not enough for you. You want to add more types to it. So what you can do then is I can right click digital asset and save as, and then immediately, you know, got the window. I can enable use my namespaces and versioning, display branching labels, and then, you know, put it into my digital asset folder. This is not an ice cream, so I will not put it there. Or maybe we create a cone, and then I can say maybe this will be our cone for the ice cream, so I just put it into ice cream party. Okay, and create. And then now you will see menu platonic solid. I have the one which Houdini ships with, and I have my special ice cream edition. So if I now go to ice cream party, you will see that I have platonic solids def here. And even if I just type platonic solids, now it's very much, you know, clear which is the one which SideFX ships and which is the one that you are just editing for your own purpose. So this was just a brief introduction to working with assets and how to create them. So let's now jump into the second part of the presentation, which is about file caching workflow. The cache workflow, just as well as the asset workflow, also originated from the fact that I just needed to make my day-to-day life easier, especially when it comes to creating all the pyro demos we've been presenting for 18.5 and 19, and some of them were such a, like, you know, a more complex scenes that I needed some more reliable tool or sort of a workflow that would help me easily to iterate between versions and also between wedges. And in Houdini we now provide two file caches, one which comes by default in Houdini, and this is now the file cache 2.0, and we also have a labs version of this file cache 2.0 which has extended functionalities, and I will go through both of them now and show you the differences. To start with, I will show you the file cache comes by default in Houdini. So as you can see, there has been a major UI change, and what is probably the most obvious is the construction area here. So just as with the asset workflow, now we have the way to modularly define the components of the file name, such as the path, the name of the file, the version, the base name of the file to be precise, the version number, and the file type. So all of this can be set here in a much more user-friendly way. And this also helps us. The other big difference that this node has a top integration as well, and this helps the top nodes decide, you know, what type of cache you're working with. Is it like something that is time dependent or not, and so on and so on, or a sequence, for example. Of course, you can go on and say file path, you want to explicitly define it, and in that case you can return to the old way. But as I said, many functionalities probably will be, you know, like will be lost, and you have to take, you know, very good manual care to make sure that everything works accordingly as you would want to. So I will just leave it unconstructed, and I have a box here, so no animation, nothing like that. So this cache I consider as a time independent cache. So like models, terrains, etc., etc. In this case, the way I would cache this is just disable this time dependent cache. So as you see, the sequence entry which define your frame range are completely gone, because this file will be only saved, or this cache will be just a single file without any reference to time in the file name. So I just click save to disk, and you see immediately I am getting the box, and this is already reading in the cached file. In the advanced setting, there is this option to enable load from disk on save, and also to harden the expression you have here. And you can turn this off if it's something that you don't like. And to make something then animated, and then I will just now put down and just create some basic animation here, as you can see. So now the box is moving, and I probably set my timeline to something much smaller. And then the way I would cache it is just enable, time-dependent cache by default. And here I have two major categories again. You either save something as a simulation, which is our default, which means that things gonna, like each frame needs its previous frame to cache. So this is a very sequential kind of way of caching, but this is what you need when you caching something right of a pyro simulation, an RBD simulation, etc. If in this case this is a sequence which actually is not coming from a simulation, this is something that it's a sequence that is kind of frame independent from each other. So one frame does not depend on the other one. So these are the caches that are much faster to cache, because you can assign multiple processes to do it. You can assign multiple computers on the farm to deal with the subsection of the frames. So in this case, I just disable simulation. My frame range is 1 to 10 to 4. And just to show you how top works, I just click save to disk. Yes, I want to save the scene, and you see it just kind of chunks through all the caches. And then you can see that I'm reading the cache in which I saved, and now this is moving according to my animation. And we have this icon here, or this badge, which shows that this is actually now loading from disk. If I enable it, you see that it shows up, and this will show up on any asset you do which has this load from disk parameter. So you can assign it to your own digital assets that deal with file caching. So I would take this a step further, and just as with any proper work scenario, you would probably have your FX or whatever you do. In this case, I just say FX created from start to the beginning with multiple of these file caches. So I will just put down a transform node, and let's say I just move this up by 1 unit, and then put down another file cache, and just connect it, and I will just leave it at simulation and save to disk in background. And you will see now that voila, I got the box up in the air while the first one is just on the ground. So now this will allow me to, let's say, what if I want to have now red boxes, because this is what I have to do now. So I actually gonna grab this version on the first one and connect it to the second one as a reference. So now I can, I have my red box here, my cache is still white. I can change to a second version, and the second file cache also changes too. So that's great. Now I just have to cache this one, and I have to wait until that one is finishes, but I have my red box here, and then now I have nothing here yet. I have to now again click and cache, and then as you see, I have here my second red box here. Let's take it one more step further, and that would be the fact that after I set up a graph like this and I want to run, my version 3, let's say, I do not want to manually wait until one finishes and click to the next and so on. Or when I leave for the night, I just want a system that would run all of these file caches one after the other. and that's where PDG comes handy. So to set up something like this, and I will show you it manually, so just bear with me because I think this is important to understand what's going on. So rough geometry, I just simply point it to a color sub here, and then I go to advanced path output file. I just general reference it, this one here. That's the simplest way to do it. So now this rough geometry is caching basically this one. So this is the PDG equivalent of this sub now. Then to create the second one, I just simply cheat here and I just say transform here. And then I also just simply change the number here to 2. So now this is kind of, matches with this one. So now, ideally, if I've done this now, I should be able to just cache this and then leave for the night, right? And that's not the case because you see here, I'm only getting one work item by each node. And the reason for that is because we have here also an evaluate using option, and right now they are both set to single frame. So because you're doing sequence here, and this is what I was kind of mentioning with that's why I was explaining the cache type kind of, like static model and time independent caches. You also, because we work with sequence, you also have to make sure that this is a frame range. And the second one I set to frame range because, this file cache also say that, this is a sequence. So if I now generate this guy, oops, you see that again something is not right, because now suddenly what's happening is that frame range actually says now that for the second node that I want to generate another 24 frames on top of my original frame. So this is clearly wrong again. And the kind of confusing thing is that if you now just disconnect and regenerate it, you will get 24 because now we don't have input. And it's very common that an artist would disconnect things here, and they would expect certainly that the graph just stays the same and run the same, but this is not the case actually in TOPS, which is a pretty big issue, I think. But what we have now is an automatic option. So I can set this to automatic. I can set this to automatic as well. And then now, if I just show you without disconnect, when it's disconnected, you will see that I'm still getting 24. And if I connect it, I'm also getting 24. So this is basically now ready then to cache, and I will get the same result while running this PDG network as I would run this two one after each other. Then I will take this one more step further, and I will introduce wedging into the system. So I actually want to put down a wedge node here. And then I set 5 wedges, and I set my ice cream color, and I just leave it as float. It doesn't matter for this example, and I will just override this color. So when I generate this generate node, you can see that this color node, it's actually nicely updating based on the values this work item provides. So I have this rope geometry here, which was working before all fine. So I just connect up wedging here. And if I want to regenerate it now, believing that it's all fine, then it's not. Because now suddenly the automatic here does not work as expected, because, well, automatically simply saying that, I have incoming work items, so don't do anything replicating thing, naturething with that, so just leave them. It will really just leave the 5 wedges, but what we would be expecting is actually 120 work items here now. So the solution for that is then change our network again and switch to frame range. So now when I generate this, you will see that it works accordingly. So now the question is, are you able to just run this network and go home and expect good results in the morning? And the answer is not at all. So the reason is being because, as you can see already, where the complication starts to arise is that suddenly this rough geometry representing this file cache, suddenly this has 120 work items, while this one only works with 24. And this file cache is not aware of wedging, while this rough geometry does have all the work items set up for wedging. And as being this also the output file which evaluates here, it's also not valid anymore for this node, because this node has to encompass the wedge index attribute. And I just type in big wedge so that you see here. So now if my third wedge is selected, you see it evaluates to wedge 3, while this caches do not. And then now you kind of have to then cross-reference this one into here, or do some other kind of manual setup to make it work. And this is where things really falling apart. Even before that, you could already see that the entire topnet setup, it's kind of painful and manual for a user. And on top, adding wedges and just completely like desync these two nodes, it's just creates sort of a nightmarish workflow for the user, in my belief. And that's why we are introducing also the labs version of the file cache node, which is very much still in development, but it's trying to tackle these issues and help you, creating more to help you work with in a using file cache in like realistic, shot-like work environments. So I will go and replicate this setup now using the labs file cache and see how that one is compared to the default file cache. So I will actually put down a file cache, and I will put down a file cache labs version. You see the two interfaces are rather similar. One thing is scheduling. On the base one, you will only have the possibility to override to provide a custom scheduler, which is again a very manual way to do things. While this one on the scheduler tab has the option by default to set how many cores you want to use for this process. Let's say you want to use more for simulations, less for sequence caching, etc. And one of the things I changed here is the fact that if I go to local scheduler and I see here total slots to use, and basically slots, I never know what it means, and it's hard for me to grasp. Is it now meaning logical or physical cores? Like, just always have to go to the help, check it what it is. And all the option I have here is either 1/4 of the total CPU count or equal to less than 1. So this is not very much helpful for me. And what I did is I just renamed it logical cores to use. And here now we have 1/4, 1/3, half, 2/3, 3/4. So you have plenty of more options to choose from, and hopefully in a manner that actually shows the logical core numbers, and in a manner that's easier to judge how many core per work item you want to assign them. The other really cool lab feature is that wedging is now brought to labs through the file cache. So the way I would declare a wedging is through the file cache, I enable it, and boom, I can just set the number of wedges, and these are right away showing up. So I can, create an attribute here, and I can just copy this, say add wedge attribute, and then as soon as I just force it to evaluate, you can see that I do not have to go to tops to see right away the changes in SOP level. So this is really cool. And then one other thing we did is to reverse how you create this wedging. So what I just did now is the opposite way. So when I do a wedging, let's say I put down a wedge top node here and I define I want this attribute to be, I don't know, whatever, and I set it up, and then I have to go on and then set it up where I want to. To me, this is the actual reverse thinking of how a user would set up wedges. It's like going from backwards. What now we can do in labs is to do it the kind of right way. So when I'm working, I want to say, okay, this is the parameter I want to wedge. I just want to click on this and then say, you know, this is what wedge for me, please. So this is what exactly I can do. I can right click here and then I can go to expressions and wedge value. And then this will bring up the option to which wedge node I want to wedge it. And in this case, this is the file cache. And then I just click accept. And then suddenly now I have that attribute. And then I just kill the previous one I used for the example. So I just set color R channel to 0 to 1. And now you can see this updates accordingly. So I think these are all really cool features. And there is one more which the topnet or the topnet version kind of fails. So I kind of call it this wedge node, it's all and nothing, because if I again create an attribute and I say I want a vector or I want a color, how do these colors or vectors interpolate into each other between the wedge values? Like, there is no way to tell it here. There is just not enough, you know, space or UI to, like, it's a very complicated way of defining these relationships, and simply this node just does not provide any kind of answer to how to do it. And that's why, like, you know, we have a color option here, but it's pretty useless from my point of view. And especially that we have attribute adjust color vector nodes that are actually dealing with exactly this problem. How do you define these attributes in Soplan? So as you notice, these interface for attribute declaration is much more simplified. And we have a very cool features now, which you can see if I kill this one again. And instead of just creating a single float, I will create a color. So I will wedge the entire RGB channel. So I go here, expression, wedge value, I select the same file cache. And now what you find is that it created a little network here. And it set the attribute values options here. So what it says that the actual wedge values, the attribute values, should be coming from this geometry. And if I open up a geometry spreadsheet, just here, you will see that I have exactly as 5, so I have 5 wedges, I have exactly as many points, as many wedges, and each wedge now has the color parameter. So this is really awesome, because here you have all the freedom in the world to change these and modify individually all the subtools to change them. And then these could be read in either as point attribute, primitive attributes, etc. Does not matter. And I can just force it to evaluate, and then you will see now that I'm getting all random colors as per I defined it here. After this, then let's create a topnet. From this, and let's add our second file cache. So what I can do here now is a new feature here that you can click on this top hat icon, and this will create a labs top file cache, which is meant to be the kind of equivalent node of this file cache in subnet. This does not meant to be used by its own. It's simply there to reference this node and run the work items. It's kind of like fetching. And then I will just put down a transform sub here. And what I will do is just say, well, actually, I have a really handy expression here put in, which is set to wedge index. And then I immediately can see how my wedges actually each different wedge, just gonna move up based on that wedge index number. And I can do a labs file cache again, and here I also have to say how many wedges I work with, which is 5. So, but here I do not need to do anything else. And I also click here this top hat icon. And now if I generate this node, what I also have to make sure is these are all set to load from disk. But other than that, now these 2 nodes are all set it up, all providing me the correct results. So I can just save and run it. So that's the idea behind it, that this was very simple to set up without any knowledge of topnet or any kind of laboring, manual work. And now what I can see here is, you can see here that I'm loading this. This graph cached exactly the same thing as I have here, and I can check it in labs as well. And some of the new features here, which are really cool, is in the load option, I can say I want to load all wedges. So now you see all of my wedges are loaded, but I can also say load each frame of my sequence, or both load each wedge and each frame. And this creates a couple of interesting scenarios when build your topnet. For example, now this cache is actually acts like just like a static time-dependent geometry, because by merging all frames, we took away the time dependency, and by merging all wedges, we do not have anymore any kind of wedge indexes. But the idea is that the next file cache node you put in, you want to now just raise it up again by 5, and then this is time independent. And actually I have to put down a labs version of it, so just say it's time independent. I raised it by 5, I put down the next one, and then let's make sure that this is loading. And then when I do this, even though you now see 1, this works exactly as expected. But when I see my caches, you see that this one actually moved up as expected, and this is one single frame. So that's the idea behind connecting SOPs and TOPs and providing these file caches. So this is much easier to handle. And the other thing is, which is really nice, let's say I want to render now these geometries, but I do not want to merge them together just yet. So I have here the animation, and what I can do is click on this geometry icon as well. And what it will give me, it's a nice cake with a rendered geometry object with a nice cake. So what it does is, again, this is like, you can consider it as a special geometry node which meant for rendering. This is something we never had in Houdini, and kinda when before labs, this would have been very, very handy to use, because everybody was just putting down their own geometries, their own object merges and so on. And this is actually very handy because this connects right into this file cache node. So all I have to do is point this to it, and then I already have a renderable geometry I can point to my render. But again, in labs, in LOP and Karma and using the stage context, you can also just scene import this geometry as well. So it's not completely irrelevant still. And what is nice about this is that I do not have to set merge wedges here on the node. I can just say merge wedges for my rendering. So you can see here now, if I just change the full geometry, that I also have the same option here. I also have, I can just do custom range as well. So if I do a big forest fire with different wedges, I do not have to do any sort of combining operation. I right away can just merge things in, and then I can also merge all the frames if I want to, and render everything right away. So this is very, very handy, and you of course have a submerge option. So if you want, you can set it to submerge and just provide your own geometry. And this has the nice options that it's kinda has velocity blur and kinda all trying to be organized about how you apply velocities and stuff like that. And this is, again, this is for more mantra kind of times. But that said, this node also the idea, so these are all still work in progress, and we still have to evaluate them now, especially with labs and how we go forward with them. And one of the nice feature is, for example, it's like could be handy to say that I want to say this is an RBD-IO geometry, and if I reference an RBD-IO, then it automatically sets me up the best way how I can render that geometry. So there could be lots of really cool things to do about a dedicated render geometry node. And pretty much this covers most of the file caching. One other feature which is I put there as a test is performance logging. So with this enabled, you will be saving a performance file that you can load up with the performance monitor later and check your statistics. And as a last thing, I want to show you more of a real-life example on how to use these tools. And here I just put down a fireball, and my intention is to set up wedging and also render these wedges as each separate renders. And as you can see, just a simple fireball setup with a transform to use as my wedge parameter there. I set it up the way I explained it before. And with the Pyro quick setup, I created a LOPNet for rendering. And the nice thing in here is that I'm using the Labs Karma LOP node, which is in the interface. If you see, it looks exactly like the file cache. It has the wedging option and the rendering settings. I tried to like combine it in a way that reflects the simple folder structure new to 19. And then click the top hat icon as well, which generated me a node that is mirroring this node, and I just set it to render. And one of the things I can show you now is that, and you can see that I can just, also the caches, I can just go back and forth with them. And let me just show you here on this one, on the Labs Karma render. I click on this icon to load the render, and you see I have one partial render right here, but I can also select the last frame, or sorry, not the last frame, the last wedge, and then I just select it from here because it's simpler than finding it from these work items. And then just a moment, and then I'm getting that one also written, so you can see that the placement is rather different on both images. So indeed this is working well, and I immediately have 5 edges rendered. So that's the basic idea behind the Labs file cache workflow and bringing in wedges into subs. So there is still a lot to iron out, but it's in Labs now, so feel free to, try it out. So thank you so much for listening, and see you next time.